Hello, children. Your semester 2 exam is round the corner. I mean, you must all be gearing up for your exams. I have prepared revision notes for maths. This particular video is on coordinate geometry, and the first part of coordinate geometry that I'm handling is distance in section formulae. Please note that this is just a revision note, and I'm not deriving the formula over here, just in short revision notes for your exams. So let's get started. So the first part is the distance formula in one dimension. So a distance formula in one dimension, you can take the real number line. If I have the real number line, this is suppose a Raman number line, and you have uh, three positions over here. One is the school, the house, and you want to find out the distance between the school and the house. In order to find out the distance between the school and the house, all we do is we are doing modulus of b minus a, which will give you 5 minus of minus 2 is equal to 7 units. Now we can actually also do modulus of a minus b. This will be equal to modulus of minus 2 minus 5, which will be equal to modulus of minus 7, and that is going to be equal to 7 units. Two things you need to remember over here. One is I have written units because I don't know what is the distance between minus 2 and minus 1 each individual the same. It could be kilometers, it could be centimeters, it could be meters, and because I don't know, even in your graphs related questions, you are always going to write only units over here, 7 units, 7 units. The second thing you need to remember is that distance is always positive. Distance is always positive, and therefore we are taking the modulus. Therefore, whether I do b minus a or a minus b, it turns out to be the same. The answer turns out to be the same. So now we go from one dimension, we are now shifting to two dimensions. So it's now we not only have the horizontal axis, we also have the vertical axis. So the x-axis and the y-axis. Here I have 2 points A and B, where A is having the coordinates x1, y1 and B is having the coordinates x2, y2. That means my AB is the distance between A and B is given by the square root of x2 minus x1 whole square plus y2 minus y1 whole square. I can also write down square root of x1 minus x2 whole square plus y1 minus y2 whole square. It's going to be finally, you will finally get the same answer whether you do x2 minus x1 whole square plus y2 minus y1 whole square or x1 minus x2 whole square plus y1 minus y2 whole square. Now let's see what are the types of questions that we come across with the simple formula of distance. The first one is going to be to find the distance between 2 points. There's no need for any explanation beyond that. The next one is you are given 3 points and you have to find out whether the 3 points are collinear points. Collinear points meaning that they are in the same straight line. In order to do that, what we do is that these are the 3 points A, B and P. A with x1, y1, B with x2, y2 and P with x, y. We will find out the length of AB. We will find out value of AB. We will find out the value of PB, and then we will find out the value of AB. And you find that if this addition of this two is equal to AB, it means that A, P and B are in the same straight line. A, P and B are in the straight line. Now, when you have values like suppose AP is equal to root 2 and PB is equal to root 3 and suppose AB is equal to root 5, how do I add root 2 plus root 3? Not possible. So what we do is we will instead find out AP square. So when I do AP square, this root 2 will become PB square. You see this AP square plus PB square will be equal to 2 plus 3, and that is going to give you AB square will give you 5. So it becomes easy for us to understand how to find out the value of AP square plus PB square is equal to AB square. And that is the reason we can also use this method of doing AP square plus PB square plus AB square. Okay, then the next type of question is the possible questions are going to be that you have to find out whether you are given 3 vertices and you have to find out whether they are the vertices of an isosceles triangle or whether they are the vertices of a right angle triangle. So for an isosceles triangle, simple, you will just find out if any two sides have the same value, that will give you it's an isosceles triangle, otherwise, or whether it's a right angle triangle. After the distance formula that we have learned, we are now learning the section formula. In section formula, we are looking at the point P, which is dividing the line segment AB into parts M1 and M2. So AP is to PB is the ratio is given by M1 is to M2. And when the point P divides the line segment AB in the ratio M1 is to M2, we want to find out what are the coordinates of the point P. So the point P, the coordinates are given by this formula, that is M1 x2 plus M2 x1 divided by M1 plus M2. And the same way the y coordinate will be M1 y2 plus M2 y1 divided by M1 plus M2. Please note, we are going cross, that is M1 and then going to x2 plus M2 into x1. In the same way, M1 into y2 plus M2 into y1 divided by M1 plus M2. Now, when P is a midpoint of AB, your AP is to PB is going to become 1:1 because they are both equal parts. And therefore, the coordinates of the point P will be given by x1 plus x2 divided by 2 and y1 plus y2 divided by 2, because your m1 and m2 becomes 1 and 1, so it straight away becomes x1 plus x2 and this 1 plus 1 will become 2. Over here too, this is going to become y1 plus y2 divided by 2. Now to find the coordinates of the centroid. I hope you know what a centroid is. The meeting point of the three medians of a triangle is called the centroid. Medians meaning that you find the midpoint of a side and you join the midpoint with its opposite vertex. So you do that for all three sides, that is this vertex with the midpoint on the opposite side, this vertex with the midpoint on the opposite side. This point, that meeting point, is called the centroid. The centroid is given by x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 divided by 3. So now let's look at points of trisection. What do we mean by trisection? We are saying that the line segment AB is being divided into 3 parts by the points P and Q. So that in such a way that AP is to PQ is to PB is equal to 1:1:1. So all 3 parts are of equal sections. In order to find the coordinates of the point P over here, what we do is we will look at AP is to PB to be equal to 1:2, and to find the coordinates of Q, we will write down AQ from here to here. AQ is to QB to be equal to 2:1. So to understand the concept of trisection better, I have taken an example over here which says show that P is a point of trisection of the line segment joining A and B, and then hence find the value of M. M is in this y coordinate over here. So A is 4, minus 2 and B is 1, 4, and P is a point in between AB. Now this P will be a point of trisection if AP is to PB is equal to 1:2. This should be trisection. Since I know the value of the x coordinate, I am using the formula for the x coordinate, that is for x coordinate of p, x is equal to m1 x2 plus m2 x1 upon m1 plus m2. That means my 3 is equal to 1 into m1 or m1 into 1 plus 4, this 4 into m2 upon m1 plus m2, and when I simplify I get m1 upon m2 is equal to 1:2. That means m1 is to m2 is equal to 1:2. The ratio m1 is to m2 is equal to 1:2, and it gives us p is therefore the p is the point of trisection. So the first part I have proved over here, that p is a point of trisection. In order to find out the y coordinate m minus 5, I am going to use y coordinate of p formula, that is y is equal to m1 y2 plus m2 y1 upon m1 plus m2. But y over here is equal to m minus 5, so I am writing down m minus 5 is equal to, now I know m1 is 1, so 1 into 4 plus 2 into minus 2. 1 into 4 plus 2 into minus 2 upon 1 plus 2. You can see that the numerator is becoming 4 minus 4, which is equal to 0. That means m is equal to 5.